Okay, so I was actually explaining how to use the priority table that I had sent yesterday. So that priority table that you guys have actually, it gives you what group has the highest priority, what groups comes first, what group comes second. So the way it is done, starting with the carboxylic acid is the highest prioritized, and then it starts coming down. So when you are searching for what functional group has the highest priority, you just go onto the table and check. So for instance, question 1, I have two functional groups, a triple bond and a double bond. So you want to find which one comes first in the naming system. You are going to discover that the double bond has a higher priority than a triple bond in the naming, meaning the group with a triple bond is going to become the substituent. Okay, so in this particular molecule, you have these two double bonds, you have a triple bond. So if you check, you have 1, 2, 3, 4, 5, 6. You have 1, 2, 3, 4, 5, 6. So you don't consider this when you're counting your longest chain, because these two double bonds are supposed to be in the, they're supposed to be, since they are the ones that have the highest priority, so they're supposed to be the same. Okay, they're supposed to be counted when you're counting in the same carbon skeleton. So therefore, this is a substituent here. This is a substituent. Now, when you go to the alkyl where the triple bond is and where this is, you find that they have the same number. So since they have the same number, you will go where the alkyl group is, and this becomes a substituent. Okay? Or, so your numbering is 1, 2, 3 there, 4 here, and then actually 4, you don't count where the alkyl group is, because the all of this group is going to be considered a substituent, the all of that group. The all of this group is going to be considered a substituent. So you have 1, 2, 3, you have 4, you have 5, and you have 6 there. So this is your molecule. This is two groups. In ActoSense, it's supposed to be an alkene, okay? It's supposed to be an alkyne like this. But since it is a substituent, what you do is you will remove the final E, okay? And the name from the alkyne, you will remove the final E and you put YL like that. It's a substituent. So this is alkanel. So this is ethanol. Okay, it is an ethanol like that. Okay, it's an ethanine like this. Instead of calling it like that, you will remove the final E and the name will become alkanel like this. So this is that name there for your substituent. Then this is 1, 2, 3. This is a prop. What's wrong now? This is a prop PU like that. Okay. Now, these two substituents, you check which one comes first in the alphabet. P or E, you will find that E comes first. So in naming this particular molecule, this is on position number 6. 1, 2, 3, 4. It will be 4, 3, and then you're coming to naming the whole thing. So on position 1, position 2, you have 1, 2, comma, position 1, comma, position 3, 1, 3, and then the O of this is eggs. Here, diene, like that. Or just on the last part here, you start with eggs, and then you put 1, 3, diene. You have two options of showing where the double bond is. You can either put it inside like this, or you can put it outside like it is in this particular scenario where we have put it outside and we're saying it's 1, 3 diene. So you can name it like this, or you can name it like that. The choice of which one to go for depends entirely on you. We are not, and they will not penalize you for actually doing that. Okay, so that is on the naming of this particular molecule. So that priority table, try by all means to solve as many nomenclature questions as possible so that you get to master the priority table groups, so that it becomes easy for you to actually describe which one comes first. So for instance, B, I have this group and I have that group and I have, so this is the alcohol as the highest priority. So this particular molecule.
Sir.
Yes.
Sir.
Yes, please.
Just a quick question. Yeah, just a quick question. The reason why you didn't choose the longest chain to be on the first one.
Yeah.
Yeah, the reason we didn't just choose. Yeah. The reason why you didn't choose that to be the longest chain was because of that group at the far end, right?
This.
Because it was also giving us 6 carbon.
Yes, but that's a substituent.
Oh yeah. Okay.
Yeah. Okay. Any other question?
So, sir, if at all it didn't have that functional group, could have counted to be the longest chain, then this ethyl could have been a substituent, right?
If it didn't have what?
If at all, maybe in some cases it didn't add that functional group, the one you've circled. I was saying we can count it to be the longest chain, then the ethyl, when I say ethyl methyl could have been our, what's this, our substituent.
If our ethyl were I'm not quite getting if what was the substituent?
So she's saying if the alkyne,
Yes.
the alkyne group wasn't there,
Yes.
then you'd have taken that as your own chain.
I would have picked any side because any of these sides has the same number of carbon atoms. So one of them would have been the substituent and the other one would have been the part of the parent. But I would have definitely picked one. So I would have either come this side or gone that side. If this was not the group that was there.
So, sir.
Yes.
Why didn't you start with the propyl group coming down being your longest carbon chain?
This side.
Yes.
These two are have higher priority than that one. So these are the functional groups that are naming this particular molecule. And therefore, you should include the functional groups in your numbering. So my numbering definitely starts from there. And then I start looking where this can go. So this is my other point. So I can't put a number here. And then you go up there. Once you go up there, you are not considering this functional group. So you completely count the double bond. So you start your 1 there, your 3 there, your 4, and then you check where it will turn. So this was not part of where this was running. So this is a substituent therefore, because an alkane has a lower priority than an alkyne. I mean, an alkene.
So in a case like this, if we had what's this, 3 bonds, like if we had another alkyne group in the molecule, then we choose the alkyne group to be the one naming the compound.
If you had another alkyne group where?
In the molecule, for instance.
So we put it where? So say we put it here. It becomes like this. Aka.
Yeah.
Yeah, it
Yes,
becomes
sir.
like that. If your molecule becomes like this, definitely one of these should become your substituent. So you will look at which side gives you the longest, because not all sides will be counted. You can't count going this side and then you come back. So definitely you will start from this side. 1, 2, 3, 4, 5, then 6, 7, because this side is giving you a longer chain as compared to the other side. Therefore, this will become the substituent. Does that answer your question?
Yeah.
All right. So we are on naming the second group here. This is your parent, the alcohol. It has a higher priority than the chlorine. So that again, here, actually, you have the alcohol, you have the chlorine, and you have this molecule there. That is also a functional group on its own. Okay, so since this is a functional group on its own, this group is going to take a higher priority than these two. So this is going to be a substituent and that is going to be a substituent. So your counting will begin from here, 1, and then because this has a higher priority than 1, so that is 1, 2, 3, 4. That will be your fourth group. When it comes to naming, this will be 1-hydroxy. So you just say which one comes first. The chlorine comes first because of C. So this is 4-chloro. That is 4-chloro, 1-hydroxy. Benzene. That is your name, 4-chloro, 1-hydroxy benzene, because the benzene ring takes priority in that particular case. But otherwise, the hydroxyl together with the benzene, okay? The hydroxyl together with the benzene, when I do this, the hydroxyl together with the benzene, this O molecule, this O group is called as a phenol. That is a phenol. Like this. Okay, so if I take this to be a phenol, then I'll start my counting here will be 1, 2, 3, 4. Now, if this is a phenol, these adjacent carbons are called ortho positions. These positions after the ortho are the meta positions, and that position is the para, P. So in the other naming system, I would say this is para-chlorophenol. Para-chlorophenol. Like that. Like a small p and then chlorophenol. That is when you are using another accepted IUPAC naming. This is also accepted, para-chlorophenol. Okay, so you can either say 4-chloro-1-hydroxybenzene or para-chlorophenol. Both will be marked in this particular case when you have the benzene ring. Okay, so a phenol is a common name for that particular part, but it is accepted under the IUPAC naming system, and it is going, you will find it being used in many texts. That particular naming system I've seen there. Yes.
Sorry for interrupting. On the bonds which are inside, I saw in some other book and in some other books that I was like reading, they represented them as a circle, like to put a circle inside. Is it okay, or maybe there was something
That's just
wrong?
a hybrid. When you are writing the benzene as a hybrid, these bonds are not stationed like that. They are not fixed. They move, they interchange. This is a conjugated cyclic molecule. Conjugated meaning these electrons can move, they go there. These ones will move from here, they come here, and these will move from there, they go there. Okay, so in a system where these do this, these electrons do this, they'll change position. They will be there, this will be here, that will be there. Now that is a continuous process. The changing of the bonds happens every now and then. So that is why mostly you're going to find you just put a circle inside. Once you put a circle inside, you're just showing that it's a hybrid, but it doesn't mean it's different from this. No, it's not. It's just that once we do this, we are just trying to say we captured it at this particular moment when the bonds were in that particular form. You can carry out a reaction anywhere and you write these bonds differently from the way they are, and you still be marked so long they remain conjugated. You understand?
Yes, sir. Thank you. And then I can know how the bonds are positioned through the same circle, right?
Yes.
How can I like identify?
Huh?
How can I like identify the bonds? Because there the bonds are 3. So if they've put a circle inside, how can I know that there are 3 or maybe the
Whenever they
hybrid, that
just
will
put a
try.
circle inside, it means there are 3 bonds here. They're just showing that. So if you check, you have done resonance structures. If I get the benzene ring, what happens is that there is your benzene ring, okay? There is your benzene ring. So what happens is that these electrons can move there. When they do that, they push these that are here to go there. And when they do that, they push those to go there. So your benzene ring instead will come and appear with bonds here, here, and there. Okay. So when that happens, it will simply mean that the bonds have actually shifted and your molecule is going to be like that. So they'll put a circle just to represent the hybrid. Patrick, I'm in class. Let me call you.